Today we're doing 5-1, solving a system of equations by graphing. You're working on a big ideas book. I've switched the homework to 239, 1 through 27 odd, with 1 through 22 being mandatory, 23 through 27 odd optional. Try and attempt them, see if you can write the equations. The objective today is to solve a system of equations by graphing. All right, I asked, what is a system of equations? And Luca raised his hand and said that it's two or more equations grouped together. So if we look at the definition, it's a system of equations when you have two or more equations using the same variables. To find a solution, or if it says solve the system, or even just solve when you see a system, the solution is the point that satisfies all of the equations. If we looked at a graph, it would be the point where the lines intersect. If you look at the equations and we look at, it would be the ordered pair that works for both equations. Pause the recording if you need time to write this. Okay, so one scenario that you will encounter of the three possibilities is intersecting lines. To find the solution, we look at the point where the two lines intersect. In this case, it's 1, 2. All right, the next situation, we will have parallel lines. What is the solution to this system? What is the solution to this system? Annabelle?
Would there be no solution?
There is no solution because there's no intersection. You will notice in this scenario, when they are parallel, there's no solution. If you have the two equations and it says no solution, it means that they're parallel. The converse is true as well. Now, you'll notice, look at the slope. It's the same. But what's different is that y-intercept. The difference is the y-intercept. So parallel lines have the same slope with different y-intercepts. Questions? Okay, pause the recording if you need to write this down. All right, now the third scenario is something called coinciding lines. Okay, a coinciding line is really when one line is lying on top of the other, which means it's the same line. They are the same line. They look different in the equation, but when you get that y all alone, they are the same equation. Okay, if you notice, in this situation, when we look at the how many points are in common? What is the point that's in common? All of them. All of them. And so we say infinitely many solutions. Okay? Because they both have the same slope and the same y-intercept. This might come to us in the form of, like, if I had, let's say I have, what is the equation of the line? I'm going to say my m is a rise of 2, a run of 1. And my b is -1. So this equation would be y equals 2x minus 1. Y equals 2x minus 1. Now, when we have y equals 2x minus 1, they might give it to you like this. 2y equals 4x minus 2. Same equation. What's the difference? What's the difference, guys? Luca? It's not simplified. It's just everything's multiplied by 2. If I get that y alone, divide everything by 2, I end up back with y equals 2x minus 1. Do you understand? Or I could have something like this. Minus 4x plus 2y equals -2. These are the same equations. This. The only difference is we have to get the y alone. Okay? It's basically one equation and the other one's laying on top of it. It's the same thing. Infinitely many solutions, infinitely many points in common. Okay, can I erase that? All right. Yes?
Would it also be all real numbers or not?
You would generally say infinitely many solutions because they'll say solve and you have to list the solutions. All right, now we're going to try solving by graphing. Not my favorite method, but definitely a method that gets used is solving by graphing. I don't like it because it doesn't work for every system. For instance, if I were to have, well, let me show you why well, let's first graph this system and then find the solution, and then we'll talk about why it doesn't work for every situation. When I have y equals 2x minus 1, how do we go about graphing that? Annabella?
We would start at -1.
No, before I even start, I have to do certain things in my work. Yes.
We could also make a table.
No, we don't need to do that. Yep.
Interpret the slope and y-slope.
We don't need to interpret here. We have to identify. Identify. M equals 2, my B equals -1. You must identify. If you're going to take this shortcut, you must identify those items. Interpret means tell me what they mean. Identify means say what they are. So I'm going to start now, as Annabella said, at -1. And I'm going to rise 2, run 1. Rise 2, run 1. I really only need 2 points. More than 2 points just makes my line more accurate. I can do -2, -1. -2, -1. And now I take my line and I draw it. Okay, and then I take the other equation. Let's do a different color. Okay, now I'm going to take my y. Does this look like a different color? Okay. I'm going to do my y equals, no, x plus y. I like to kind of switch it up. X plus y equals 5. I like to practice both methods of graphing so I never lose that other skill. Do you guys remember what the other method of graphing is? Shaylin?
Was it the table?
No, the table takes too long. I'm done with that. Unless it's a quadratic or a kind of equation I'm not used to, I generally don't use it because it's timely. Ryan? Yeah, we're going to do solve by finding the intercepts. X-intercept, y equals 0, y-intercept, x equals 0. So, x plus 0 equals 5, so this is x equals 5. So what is the ordered pair there, please? Jack?
The ordered pair for which one? For that one. It is 5. It's 5, 0.
Good. And then the y-intercept, I'm substituting 0 for x plus y equals 5. So y equals 5. What is the ordered pair, Jack?
0, 5.
Good. And so I plot those points. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I gotta find my purple. I don't know what happened to it. Okay, there we go. Okay, and now I'm going to do okay. Questions? All right, now, are we done? Are we done? Why, Shaylin?
Because you have to see where they connect.
We want to see where they connect. And where do they connect, Shaylin? 2, 3 right here. That is the point of intersection. So we would say 2, 3 in a complete sentence is the solution. In a complete sentence, when the bigwigs from downtown are in our room watching, or the principal, but you could say 2, 3 is the solution for me. Okay, but a complete sentence, solution to the systems. Whoops, I probably shouldn't say that in a recording, right? And when you're taking a Common Core test, you want to speak in complete sentences, okay? All right, so there we go. Questions? Can I erase? All right, so now we're going to move on. One thing I want you to notice is that when I do this, notice they're not solving the other one using intercepts. They're not graphing using intercepts. They're graphing using slope-intercept. I don't care what method you use. I say you should mix it up so you keep them both in your repertoire of tools to use in the future. Okay? Nobody's going to get mad at you and you won't get points off. Okay? Now, the reason why I said I don't like this method, this is very pretty and it works because the intersection is at 2 boxes. But what happens when I'm intersecting right here? Do you see that in the middle of the box? Oops. When I intersect at the middle of that box, you can't eyeball that. It's very exact. So graphing is limited. It only works when the lines are like right on the box. But tomorrow we'll start using other methods. Okay? Okay, I want you to practice one. There you go. Now you practice. Pause the recording and solve the system. All right. So let's check your work. Here's the first equation. Your M was -1. Your B was -1. Start at the -1. Rising and running, +1, -1, +1, -1, or vice versa. The other equation, starting at 2, rising +1, running 2, or -1 over -2. My solution, what solution did you come up with, Jake?
Oh, I didn't do it right because I thought I did the graph.
Did you just graph it? Now, this is a big mistake that I will have at least 25 to 30% of students make this mistake. And that is, you do all this graphing and you don't solve it. Jake, what does it mean to solve it?
You simplify the equation before you find M and B.
No. To solve, Preston,
You find where it intersects.
what?
You find where it intersects.
Find where it intersects, and where does it intersect? Look at my graph.
Oh, it intersects at 2 and 1.
Close. -2, +1. Okay? So -2, +1 is the solution to the system. Now remember, how many people forgot to do the solution? I know he's not the only one, because I see this all the time on the test. I do it. Me, the teacher. So let's make sure we remember to go back up and see what it's asking us. Solve. Questions? Okay, moving on. The next set of kind of problems that you will encounter in tonight's homework will be written like this. Now, in Chapter 3, you were given something similar that said, is this a solution to the equation? And so what would we do to figure out if this is a solution to the equation, Luca?
You have to find the slope, and if it's the same on both of them?
No. We don't need the slope. Amrit? We don't plug in math, we substitute. We substitute the equation, the point into the equation. Well, this time, it has to not only make the equation true, but both equations. So I substitute in. I say 3, and you must show this work. We don't do mental math here. We are proving our way to the end. 3 times 2 plus y minus y. Does that equal 5? Yes or no?
Yes.
Okay, 6 minus 1 is 5, so that is a true statement. Now we have to see if it's a true statement here. 2 times 2 plus 1, does that equal 10? So we say this is false. But I'm not done answering it, because what does it ask me to do? What does it ask me to do, Jake?
Oh, it asks you to determine whether the given point is a solution to the system.
Is it a solution to the system?
No, because one of them is false.
Because one of them is false, it is not a solution. So we say, no, it is not a solution to the system. Okay? 2, 1 is not a solution to the system. Okay, you guys pause the recording and do number 2.
Substitute the x and the y for the
Hold on, sorry. Zenzele found that this is a true statement because once she substituted in, you can say it worked, the point worked in both statements, made them both true. So 4, -1 is a solution to the system. All right. Now, the third type of problem you'll see tonight is where they give you the graph. And notice the directions. It says use the graph to solve the system of linear equations. How can we do that? How do we do that? Preston?
Find the point that's intersected.
Just find the point that they intersect at visually. We just look at it. And what is that point, Preston?
0, -2.
0, -2. Now, the second part of it says check your solutions. That's your work that proves your point. So I'm doing 5 times 0 minus 4 times -2 equals 8. Then I do -8 equals, +8 equals 8. Does that work? Check. Makes it true. I'm going to try it again. -0 plus 2 times -2 equals -4. -4. Does that equal -4? Check. It works. It should work because we're looking at it visually. So it should work. But this is just our method of proof. Okay? And so we say 0, -2 is the solution to the system. Questions? All right, let's move on. Now, the last type of problem is a word problem. I'm not a big fan of solving by graphing. I mean, you will encounter it, but the way they've set you up here for the word problems is kind of tough. So let's go on. Let's look at a simple kind of word problem. Let's go back to review how we solve word problems. What do we do? What do we do? Step 1, always, always, always. Shaylin.
I'll state your unknown or what you don't know.
We are stating the unknown. Okay, so we're defining our unknown. And so we've got 2 unknowns here. Pam is 120 and is spending $5 every week. Lorenzo has $20 and is saving $7.50 every week. When will they have the same amount of money? What are my unknowns? Luca? And? Amount of money. That's right. What depends on the other? Which one are we going to call X? Which one is independent? Which one is dependent? Brian, what is the depender?
Well, so the independent variable is number of
Weeks, and the depender is the
depender is the
money. So we set Y up as our depender, being money, and our X for weeks. Okay? Now we're going to write the equations. Write the equations. And a lot of times we can do direct translation. Pam has 120 and is spending $5 every week. Okay? What do I write for Pam has? Pam has. Pam has what? What are they talking about? What? Dollars. So wouldn't that be my Y? My Y equals. Then I have my 120. And is usually a plus sign or a minus sign. When I say is spending, is that a plus or a minus? Minus. And how do I show 5 every week? Yep. 5x. Right there is the equation. Okay? Y equals 120. Whoa. 120 okay, the next equation. Lorenzo has 20 and is saving $7.50 every week. What's the next equation? Somebody I haven't heard from today. How about Torres?
So y equals $20
Is saving.
plus 7.50 x.
Good. Okay? So there are equations. We can now create a table. Yes.
You said that when we're writing equations in slope-intercept form, the slope of the x always has to come first.
Yeah,
So apply
but I'm just translating directly from here. That's why. I mean, if you wrote it first, rearranged it afterwards, that's fine. Now, remember, when you do your graph, make sure you're labeling properly. What is my y-axis going to be labeled? What's it talking about? The money. And so it's got to go from 120 all the way down to $20. The highest being 120. And what about on the x-axis? How am I labeling that? Shaylin? Number of weeks. Okay? And so I'm doing... Now, let's make a table. Let's go by twos, because that's what my PowerPoint does. So when X is 0 weeks, how much money does Pam have? Ryan? $120. When X is 2 weeks, what does Pam have? Moreno?
when what?
X is 2 weeks.
When x is 2 weeks, Pam has 110.
Yep. It's pretty easy mental math. When it's 4 weeks, what does Pam have, Luca?
100.
Good. When it's 6 weeks, it's 90. When it's 8 weeks, 80. And we plot those points. Okay? I do the same thing for the other table. At 0, she has $20. After 2 weeks, she's got 35. After 4 weeks, he has 50, 65, 80, and 95. And I plot the points. Am I done?
No.
Why, Jack?
You have to go and find where they intersect.
Okay, and where do they intersect?
That is 8,
8, 80. What does that mean in the story? 8, 80. Naomi?
It would be 8 weeks and $80.
Okay, but don't forget, guys. It's the reading and the tests. What are we not forgetting, Teddy?
That is asking when will they have the same amount of money.
Right. Remember, this is crucial. You always go back and check. What are they asking me? And answer that question. So, Teddy, when will they have the same amount of money?
After 8 weeks.
After 8 weeks, they'll have the same amount of money. Or at 8 weeks, they will have the same amount of money. Okay, questions? Okay, yes.
I have to go for
Okay, all right. So that is really our lesson for today. Remember, you're doing page 5-1. Oh, we have 10 minutes.